Hi everyone, my name is Pat Southwell. I'm a licensed electrical inspector for Southwell Solar Inspections. We operate our company in Victoria, and in Victoria we're required to have mandatory inspections for all solar installations. They fall under this category for all prescribed work as well. Now in this video we're going to be going through some of the mandatory testing which is required in a solar installation, and we go through this as a licensed electrical inspector. And if you're an installer, you need to ensure that you're doing these tests too. And in Victoria, your inspector should be the one verifying that these tests are all correct. Now, it's really important to note that even if you are working in a state where mandatory inspections are not a thing, it's still really important to make sure you do all these tests, and it's your obligation as a licensed electrical worker to make sure that all these tests are done correctly and your installation of the solar is safe and compliant. This tester here is my Kairitsu Model 3132A, or commonly known as your insulation resistance tester. So this tester here, again, we've got the banana plugs which go into the positive and negative. Most of the time when I'm using this, especially for earthing continuity, I'll just have the one lead going in, and then my trailing earth lead, which I'll show you in a minute, will plug in just on the other side. This check is that there is earthing continuity between the switchboard the inverter is connected to, which is a known earth, and also the inverter, which is connected to the installation. So I've got my earth reel here. I usually sit that up on top of the inverter or somewhere where it can be in a good spot. Got my alligator clip here. So I'll connect that into my earth lead, and then clip it onto the earth terminal of the inverter. Meter's still on. So then with my prong, I'll go onto the earth bar, or whatever the main earth is. I know I've got an earth here, and we've got 0 ohms, so that's good. So the next thing I want to do is disconnect the DC conductors or the DC plugs going into the inverter. So this is the inverter that we're using. I've got my little tool here to be able to disconnect it. So just place that in, remove the positive, and then the negative. Come straight out. Alright. So then, turn my tester back on. Yep, we're still good. Still test out okay. So I've already established that we have earthing continuity between the inverter terminal here and the switchboard. So I know that that earth is correct. So I'm going to use that earthing terminal for this insulation resistance test. So I can go one of my prongs onto that terminal just here, and then the other one will end up going into the MC4 plug. So I'll go into the MC4 plug, onto the terminal, and that needle hasn't moved, and that's exactly what we want. The next test on the list is an insulation resistance test on the AC cable which goes between the switchboard it's connected to and the inverter. Okay, so to do that we're going to again use insulation resistance tester, and going to set it again at 500 volts. That's been set before. So we have the AC cable to the inverter, which goes through this conduit here and then through this isolator. So that isolator is in the on position because we're checking the whole cable in its whole entirety. And I've then disconnected the AC plug which goes directly into the inverter because we don't want to damage the inverter. Okay, so with the cables which are fitted off in the switchboard, we have the solid neutral which is in terminal 2 here on the main neutral wire. So I'm going to disconnect that cable. The conductor comes straight out. And then this second one here is the main switch inverter supply. So that red conductor here, that goes back with this one inside this conduit. So what I'm looking for here is, I'm looking for a positive voltage. So if they're the wrong way around, I'll get a negative voltage. Okay, so we've got here, got the male plug, which is the positive conductor, and then the female plug here, which is the negative conductor. So the male is a positive, goes in just there, and the female just in here. All right, make sure I've got a good connection here. And I've got 329 volts DC, and it's in the positive. So that means it's correct. So far this inverter is doing the right thing, making sure that it doesn't connect to the grid within the minimum of 60 seconds. So we'll just go through and we'll just check a few of the other settings on the inverter while we're doing this. So we're down to 35 seconds. Okay, at the moment it shows an E today reading, E total reading. I can confirm at the moment that on the screen there's 328 volts coming in, so that's good. No power being produced from the inverter, so that's good. And also there's no current as well. So that's exactly what we want at the moment because it's still in startup mode. Thanks for participating in the training course. And remember, doing these mandatory tests is not just about safety and compliance. It's also your obligation as a licensed electrical worker, and it's helping you to be the best solar installer that you can be. So hopefully you learned something in the video, or it's just reinforced some of the things that you've learned in your training so far, and it's just a bit of a refresher for you. So please remember to complete the quiz to ensure you receive your CPD points. And also, if you have any feedback, please pass on an email to us. We'd love to hear it at admin@southwellsolarinspections.com.au. Thanks very much, everyone, and we'll see you on the next video.